Hi everyone, welcome to the session. Today I'll be starting with the new module on loaders and linkers. So objective of this module is to understand the functions of loader, what is loader and what are the different types of loaders. So we'll be discussing about the algorithm which is followed in the loaders and linkers. Before moving to the uh, loader. So loader, where do we use it? What is the need of loader? Basically, when you run a program, so what happens in the program life cycle? You use different system softwares, wherein the text editor is one of the system software which will be helpful to create the program. And we use the assembler to assemble the instructions. It's basically to check the errors. And after that, we have landed into the next step, that is nothing but the linker and loader. So linker, basically it maps and it creates the executable code. The loader, which loads the program into the memory, then it is made ready, the program for execution. This is the program lifecycle in which the loader and linker combine together. Most of the loaders, which includes the linker as well, to do the linking as well as loading process before executing the program. So in order to do that, the loader has to do some of the functions. The main three functions in the loaders are relocation, linking, then finally allocation and loading. So these are the three functions which needs to be carried out by the loaders and linkers together. So the first function, that is relocation. As you know, we discussed the relocation in the assembler concepts, where in the previous module I have discussed about the assembler and the functions of the assembler and how the assembler creates the object program, and wherein the mission dependent features of the assembler, where the program relocation I have discussed. The program relocation is basically when there is a change in the starting address of the program, or to modify the object program's address, we use the term called relocation. If the relocation, the location of the program is modified, so which was different from what is already mentioned or what is already assumed, so then we can bring out the concept of relocation. So because of relocation, there is a change in the object code, as you all knew already, as you are aware that there would be some change in the object code. So what needs to be done, for which we had seen a solution of modification record. So that is what exactly it has to be done by the loader. And coming to the second function, linking, which combines two or more object programs. So what is the purpose? What is the need of this linker is it needs to resolve the external references. So whenever there is an external symbol which is used in your program, so how do we resolve those symbols? How do we get the address of those symbols? That is taken care by the linker. That is linking. And coming to the allocation and loading, so the memory has to be allocated to our program, and that needs to be loaded into the memory, and it is made, it makes the program ready for execution. So this is what allocation and loading. So these are the three functions will be carried out by the loaders and linker. Let us have a more view about the different types of loaders, and we'll be discussing about the mission dependent and independent features of the loader, and finally the design options. So what are the types of assemblers, how it works, all this working principle we are going to discuss in that. So let me go with the first type of loader. So there are different types of loader. We could see from this slide, assemble and go loader, absolute loader. So a part of absolute loader would be bootstrap loader, then a linking loader and direct linking loaders. So these are the different types. We'll see one by one what are these types and how it works. What's the algorithm for these loaders? How the linking process and loading process happens in the loader. That's what exactly we're going to discuss in these types. The first one is assemble and go loader. The name itself, we can make out that the assemble and go loader. So as soon as the assembly is getting over, so it will be go for loading. So which means that the characteristics of the assemble and go loader, we can say the object code is stored in memory immediately after assembly. As soon as the assembly gets over, it will be loading the object code into the memory so that it is ready for execution. So when you try to execute the program, simple jump instructions enough to execute the program. So what is the advantage of assemble and go loader is it's very simple type of loader. So it can be used in the developing environment. And what is the disadvantage? Why don't we prefer this assemble and go loader is because whenever the assembly process whenever there is a you want to run the program, the assembly has to be done, because as soon as the assembly gets over, the program is to be loaded and started executing. So whenever you want to run the program, so immediately the assembly has to be done. And whatever the language we use, same language only the program has to be coded. So this is the drawback we have in the assemble and go loader. Otherwise, this is very simple loader. We can use it for whenever you feel that the program has to be executed immediately. That time you can go with this assemble and go loader. And coming to the second type, that is absolute loader. So what is the advantage of this absolute loader? This is very efficient loader, and it is also a simple loader. But what drawback we have this loader, and why we don't go with this loader is because the programmer has to specify the actual address. See, as I was telling you already, that whenever the programmer is writing the programmer assumes that the program will start from a particular location. So he assumes that the program might start from 0, the program might start from 1000. But if at all we need to use the absolute loader, therein the programmer has to specify the actual address. It should not be a relative address. He has to specify the actual address. Only when the program is absolute program, when the program is given with the actual address, then only we can go with. Then one more problem is with the subroutine linkage. So it is difficult to use the subroutine libraries with this program, this loader. So how the loader is working and what is the procedure, how it works, that we'll see with the alpha. So you can see the algorithm for the absolute loader. As you could see, the algorithm is also a very simple algorithm, as like the loader. So which has the begin and end as usual, and reading the header record. What is the input for the loader? As I have already told you that the object program, which is derived from the assembler. So from the assembler, the next step goes to linker and loader, wherein the object program would be the input for the loader. So object program contains header, text record and hint record. Sometimes it has the modification record if it is required. So read the header record, verify the program name and length. As you know that the header record has the details regarding the program name and the starting address and the length of the program. So from that we can understand that yes, the program name is this, the length of the program is this, and the starting address of the program is this. We can easily make out from the header record. And read the first text record. Till we reaches the end record, the procedure has to be repeated. So while record type is not end record, not E, which is nothing but end record, begin the procedure, and the object code is in character format. If at all the object code is in the character format, that has to be converted into internal representation, that is a binary format. So once the conversion is taking place, then the object code is to be stored in the memory. So move the object code to the specified location in the memory. Read the next object program record, then repeat the same thing till you reach the end record. So once we reach the end record, then jump to the address specified in the end record. So as I have already told you that in the end record, we could see that the first executable address, what is the address where the program has to start the execution, that address would be available in the end record. So jump the control to that address specified in the end record. So it starts the execution. So this is how the absolute loader works. So it deals the object program in such a way it is able to load and start the execution. So this is the object program, so which can be given to the absolute loader, and it stores the object code into the memory as such. So copy is the name of the program. So since the starting address of the program is 1000, which is mentioned in the object program. So 1000 is the starting address, you could see in the header record. So copy is the name of the program, and 1000 is the starting address, and 1078 is the length of the program. So from the location 1000, you can see the memory address 1000 and the contents which has the object code. So the object code will be stored in the respective locations. So the entire object code is stored in the memory. It's nothing but the loading into the memory, the respective place. So this program is loaded in the memory, which is shown in this diagram. So when you have the object code representation, normally the object code will be in the binary format. So for our convenience, we always refer the object code in the hexadecimal format, because in general, for the human being readability, we always refer. That's what I think you remember when I was referring the object code. Let us say an example for B101036. I was referring you that so these are all hexadecimal address, and we used to keep the hexadecimal values for that. Even for EOF, we have kept 45, 4F, 46. So these are the hexadecimal value we used to represent. It is easy for us to relate or represent in the format. That is why we use the format. Otherwise, generally each byte of the object code will be stored as a single byte, whereas here we represent the each code will be represented as 4 bits. That is a half byte. Instead of single byte, we represent as a half byte for our convenience. Coming to the next type of loader, that's called as bootstrap loader. It is a type of absolute loader. So why do we need bootstrap loader? What is the purpose of having bootstrap loaders? As you see in computer, whenever you start, switch on the computer, when you start the computer, automatically an operating system will be loaded. How it is possible? Who has brought the operating system, and who has loaded the operating system? How the operating system is executed? So that's where we have the answer from bootstrap loader. The bootstrap loader is executed when the computer is on, or when you switch on the system, or when you switch on the computer, restart the computer. Automatically a special type of absolute loader will be executed. That's nothing but the bootstrap loader. So bootstrap loader will bring the first program which has to be executed in the system. That's nothing but the operating system. So the bootstrap loader loads the operating system into the computer. So operating system is the first program which is executed in our system that gives you the environment to run our application. So when I was telling you about the system software in the introduction part, I have told you that the system software which will help us to run our applications whenever you want to run your application. So it provides an environment. So the operating system is one of the example for system software which provides an environment where you can run your applications. So that operating system is being executed by the bootstrap loader. The bootstrap loader by itself, when you have a system software, let it be a assembler, let it be a loader, linker. So these are all the programs, the compilers. The compiler must be written in some language. So that is a program. So those program has to be executed in order to use those system softwares. So when you want to run the bootstrap loader, so by itself, it has to be loaded into the memory location. So for which we use the address 0. So 0 is the address where the bootstrap loader by itself will be loaded into the system and the memory. So it loads the operating system. So for storing the operating system, it takes the location as 0 by 80. So since it is a hexadecimal representation, we represent the memory location as such. And there is no need for the header record or any other information in the object program for the operating system. Why it is not required is because in general, when you want to know where the program has to be stored or what is the name of the program, what is starting address, you need to have the header record. So the header record gives you the information regarding the program name, starting address, and the length of the program. Since the bootstrap loader knows already where the operating system has to be loaded, and there is no point in having the header record. That's why there's no need for a header record in the operating system. Okay, so the bootstrap loader loads the operating system into the memory for execution, and the operating system start executing, and then it will lead the other programs to run in the environment. So, but how the loader loads the operating system into the memory? Okay, so what is the procedure? How it is happening? That's where we will see the algorithm for bootstrap loader. So this is the algorithm for bootstrap loader. How it executes. How it loads the program into the memory. So when you have the bootstrap loader, so the logic behind the bootstrap loader is given as an algorithm. We start the algorithm with the begin and end. We end the algorithm with end keyword. So X is the register. So that is the index register, which is used to assign address. So it will tell you what is the address of the next memory location which needs to be loaded. So as we knew already that the operating system is going to be loaded in the location 0 by 80. So that memory location we assign to the X register. And when you move to the next byte, automatically the X value has to be incremented by 1, because the memory has contiguous byte addresses, as we already discussed this in the SAC and SACXC. SAC and SACXC memory has contiguous memory location, and the consecutive byte, 3 bytes forms a single word we have discussed. And in the byte address, we can store the object. So X denotes the address where the operating system is going to be loaded. So we have the equation where the object code will be read, and it has to be stored in the location mentioned in the X register. So we use the subroutine called getC. What is the purpose of having the getC subroutine is, whenever you want to read a character, that means whenever you want to read the object code from the object program, and when you want to convert the character format into the internal representation, or the hexadecimal digit, so wherein we use the getC subroutine for the conversion purpose, and it's also to read the character. So by using the getC, I will explain the getC after this end of this algorithm. So when you call the getC function, it will be reading the character and stores the character into the accumulator register called accumulator. And the next step would be save the value in the higher order 4 bits of S. So S is also again one more register. So this is the working for general purpose registers we use S and T registers. Here we use the S register. So in the higher order 4 bits, we save the character which has been read using the getC function and which is stored in the A. From A, it is saved in the S register. Then again, we call the getC function. So the next character will be read. So when you read the next character, the character will be in the A. Now, in A, we have a character, and in S, we have another character. So this will be combined together to form a single byte, because when you read a character, so as I already told you that it takes 4 bits that will be there in S, and when you read the next character, again it will occupy 4 bits that will be there in the A. When you combine these two, that will form 8 bits, nothing but one single byte. So that is stored in the accumulator again. So accumulator can hold 20 bits of storage. So store the value in A, that whatever the value which is there in the A to the address which is mentioned in X. So X is already been assigned by 0 by 80. In that location, the value will be stored. Now the X value has to be increased, so it goes to the next byte. So when you are starting from 80, then it goes to the 81, 82, 83, it goes on. So the loop will be keep on going till there is no more input in the object program. So till the end, this process will repeat. So during this process, whenever you would like to read a character, so that time you call the getC. So what is the getC subroutine does? So as I already told you, it is used to read a character and also it does the conversion. How the conversion is taking place with the algorithm, we'll see now. And I'll show you the example how exactly the getC subroutine is converting. It is meant for the conversion also. Now, so in the getC subroutine, read one character that's stored in accumulator. And if you reach the end of the file, so 0 by 04, that represents the end of the file. Once you reach end of the file, which means your end of the object program file, then no more input. So you can jump to the 0 by 80 to start the execution. If it is not end of the file, then if the value of A is less than 48, then getC. Otherwise, if the value of A is greater than 48, then A is equal to A minus 48. So you have to represent in the hexadecimal format. That is why 0 by 30 representation is given. And again, we check for A is less than 10, then you return the value. Otherwise, A is equal to A minus 7. So this all the calculation we do for making the conversion. So normally when you have the character will be having the corresponding hexadecimal value, that is in the left hand side 0 to 9, which is represented in the hexadecimal format as 30 to 39. A to F, that is represented as 41 to 46. So using this one, how the conversion is taking place with the example, I'll show you. So this is the example. Here in 1 byte we have read, 1 byte which nothing but 2 characters we have read. using the getC function subroutine, and that has been loaded into the memory in the respective location. Say 1C is the value which has to be converted into binary format. So the conversion has to take place. So for which we have to follow certain procedure that which is given in the algorithm. Say for example, let us take 1. So 1 which is denoted in the hexadecimal format. So as I already told you that 0 to 9 is nothing but 30 to 39. So 0 will be represented by 30, 1 will be represented by 31, and so on. 9 will be represented by 39. So that is the reason. So 1 will be represented by 31 in the hexadecimal format. This hexadecimal format will be converted into decimal format and check for the value 48. So according to this procedure, if A is less than 48, then you go for reading the next character, else it has to be subtracted by 48. So since 49 is not less than 48, so it has to be subtracted by 48. So 49 minus 48, that gives you 1. So 1 will be represented as in the binary format like 0001. When you read the next character C, as you could see the value A which represented by 41, B means 42, C is 43. So C will be 43 that is represented in the hexadecimal format. Again that will be converted into decimal to compare with the 48. Since 67 is not less than 48, so it has to be subtracted. So when you subtract, you will be getting the value 19. So again the 19 is compared with 10, it is not less than 10. So it has to be subtracted by 7. So 19 will be subtracted by 7, so that you will be getting the value 12. So 12 which we convert into the binary format as 1100. So this is the way how actually the procedure works. And we normally do the conversion using the bootstrap loader algorithm. So in the bootstrap loader, this is the way the conversion takes place. And if you could see the procedure, when the object program is given to the loader, so especially the operating system, because the bootstrap loader loads the operating system into the memory. When the object code is given to the loader, how the loader will process the object code which is given in the algorithm. So in the beginning of the algorithm, it has to specify the location where exactly the object program has to be loaded using the index register. So index register is denoted by X register. So X will be assigned with the address. Then the next step would be iteration. So in this we call the getC subroutine. So getC subroutine is meant for reading and conversion. So convert the value which we read it from the object program, and it is being converted into the internal representation. So for that purpose, we use the subroutine getC. Once the character is read, then it will be stored in the S register. So again the second character will be read. Then now combine the character in S and the character in A so that 1 byte will be formed. So that 1 byte will be stored in the location 80, which is mentioned in the address X, the register X. So for that purpose, we use the register. And once the object code is loaded into the X register, then it has to go to the next address, for which X value has to be incremented by 1. That is why we do in the next step. So this process will be keep on repeating till you load till the loader loads the entire object code into the memory. And during this process, the getC subroutine algorithm is mentioned with the example. So whenever the character is read, that will be there in the accumulator, then it checks for the end of the program. So if the end of the program is reached, then no more inputs, then the loader has to execute the program. So the jump instructions will be carried out to execute the program. Otherwise, a value will be compared with 48, so that it checks the value, and correspondingly it has to subtract if the value is less than. Then again it will be checking with the value 10. If it is less than, again it will be subtracted by 7. And finally we'll be getting the value like this. So when the character 1 is read, or when the character C is read, the conversion is happening accordingly. So that is what from 1 we get 0001, and from C we get 1100. So this is the binary format which we can store inside the memory. So for this purpose, we do the conversion process, which will be done with the help of the getC subroutine. So this is the procedure for Bootstrap loader. The same procedure which is given in the program. So this is the same. Instead of algorithm, we have the program which is used with the assembly language code. The same procedure, the Bootstrap loader, it start with the address 0. So this is the reason why the 0 address cannot be given to the other programs. For the user application or user program, the address 0 cannot be given because it is meant for Bootstrap loader. And all the remaining steps will be as like what are the steps which we followed in the algorithm. This is how the Bootstrap loader works. So the next topic would be machine dependent loader functions. So before winding up the session, just to have a recap of what we have discussed in the loader. So loader is basically loads the program into the memory for execution. During this process, it performs 3 functions. One is relocation, linking, and loading. So relocation, so as the program will be modified in a different place or different location, so because of which the program relocation occurs, so due to which the object code has to be modified. So the loader needs to do the modification based on the input which is given from the assembler. And the linker does the linking process to resolve the external references. And the allocation and loading will be done by the loaders to allocate the memory for the program, and as well as load the program into the memory for execution. So these are the different functions needs to be done by the loader and linker. And the loaders will be having different variants. It may be an assemble and go loader, it can be an absolute loader, or it can be a bootstrap loader, or it can be a linking loader, or it can be a direct linking loader. So we have discussed about the absolute loader, assemble and go loader, and bootstrap loader. So in the further session, we will be discussing about the other different types of loaders, and also we are going to discuss about the machine dependent loader functions.